Okay, we are going to start looking at the Greek alphabet, right? And if you look at the green paper you have in front of you, you should recognize some of these letters, I hope, right? Some of them look exactly like the English alphabet, yes? And some of them not so much. Good Lord, did you forget where I was? Some of them look just like the English alphabet. Other ones, where have you seen some of the other lowercase Greek letters? In what classes other than math? Physics. Do you see some in chemistry maybe too? Right? And some we've talked about in here. Capital alpha and beta are kind of boring, right? They're just like A and B. And then you have the delta we've been talking about. It's the capital delta. The lowercase looks nothing like it. What does delta mean? Change. Okay, very good. And some of them have different ways to write them, such as the epsilon and used as set membership. Remember when we did that? An element of, it's in this set. And then one of the main reasons we're talking about this today is theta, because when we get into trig stuff, which is what we're doing, we are, x isn't always used as the angle variable anymore. Sometimes it's theta. We can still use x, but if it's not x, then if we're using Greek letters, we'd have theta. And just like if we've already used x, then we use y and z. If we've already used theta, then we usually move on to alpha and beta. Okay, but again, we could kind of do anything. Looking at the rest of these, you've got pi. Did you even know that the pi that you're used to is the lowercase pi, and there's a capital pi there? Sigma has two different lowercases. So does phi, which could also be pronounced phi. Some of these have different pronunciations. It's a tomato type of thing. And when I was in college, I had to memorize the Greek alphabet. I had to know capital, lowercase, and what their names were for every single one of them. And I had to make a little song in my head so that I could not fail that class. I don't remember what course it was because I had the same professor for multiple courses. I remember the guy for sure, but I don't remember what it was. Anybody know what tau is? What the value of tau is? It's 2 times pi. There's a little trivia for you right there. And other things have other meanings as well. But I'm not going to make you memorize this, but I do want you to have it. I want you to know what they look like. I want you to have something to refer to. That little the paragraphs at the top, I'm not going to read them to you, but I put it on there because it's interesting, and if it interests you, you can read it. If not, whatever. But I'm going to give you a little earworm, okay? Because there's a song that goes along with this that is to the same tune as the alphabet song that you learned many moons ago. So here we go.
Delta, epsilon, A, zeta, eta, theta, iota. Then there's kappa and lambda, mu and xi, xi, omicron, and then there's pi. Rho and sigma and tau too. Upsilon, it starts with U. Phi and chi and psi are fun. Omega, and then you're done. Learn all that and then you're set. That's the whole Greek alphabet.
Hope you're singing that all day long. All right, but I also want you to know, if you end up having to learn it for whatever reason, go to the YouTubes where I got this, and you don't have to make up your own song. Where else have you seen, or would you see, a lot of capital Greek letters? Maybe in a college. Huh? Some people don't want to say it because they think it's a stupid answer. Fraternities and sororities, right? They use the capital Greek letters. So if you're in a fraternity or a sorority, you might have to learn the Greek alphabet, because that's another reason, but maybe you only have to learn the capitals. I don't know. But anyway, there's ways to memorize it, lots of things. I don't expect you to memorize it, but I do want you to know that it's an actual alphabet and all that good kind of stuff. Alrighty, so let's move on to the rest of what we are doing. This is going on page 67 when we're done. I'll explain the pages and everything kind of when we're done. So as I told you, we're pausing on Unit 2 and going to do a little bit of stuff to prep for Unit 3 before we go back and finish Unit 2. We are starting with trigonometric functions. Where did you first learn these? Geometry, right? And the only kind of trig you do in geometry is right triangle trig. All right, I mean, it's possible that your teachers might have done a little bit extra, but probably not, because nobody has time for the extra fun stuff. So you can apply trig to triangles that are not right triangles. We are not there yet. So as far as you're concerned right now, it's still only right triangles, okay? Not forever and ever, amen, but for right now, okay? Only right triangles, don't try and do it with anything else. So the word trigonometry, that means triangle measure. It's the study of the relationships among the side and angle measures in triangles. Okay, notice it doesn't even say right triangles, it says in triangles, because that's true, but then we use right triangles to kind of get us there. So then we also have a trigonometric ratio. Mathematically, what are we usually looking for a ratio? What? I heard it. Fraction, yes. You don't have to whisper, and it's okay if you're wrong. Fraction. Compares the lengths of two sides. So two sides with respect to an acute angle, theta. So in a right triangle, you have a right angle, and then you have two acute angles. The only thing the right angle does is make it a right triangle. After that, we don't use 90 for anything. Okay, we use the acute angles. Then we have a trigonometric function, which is defined by ratios. We'll get there a little bit later. Okay. All right, so when we are trying to find trigonometric ratios and use trig on a right triangle, it is all with respect to an acute angle. So theta is labeled right here. So I'm going to mark theta. Across from theta is the opposite side. I'm going to label it with O. I know it already says opposite. Then this is the hypotenuse. How do we know it's the hypotenuse? It is absolutely the longest side. That is a correct answer. How do you know it's the longest side? It is across from the right angle, exactly. It is 100% true that the hypotenuse is the longest side. These three sides are not labeled, and we can't go by the way anything looks, right? That's a big fat no-no, because that can get you in trouble. But in a right, if it's actually at least semi-drawn like a right triangle, it's still going to look that way. But still, we can't go by the way it looks, even though it is the longest side. It's always across from the right angle, because the longest side is always across from the biggest angle. And in a right triangle, the right angle has to be the biggest one, okay? And then the other side, so notice here's my angle. I actually have two sides that are adjacent to it, but one of them is the hypotenuse. The other one we call the adjacent side. Okay. To write our trigonometric ratios, we have an acronym to help us. Who can tell me what that acronym is? Y'all stop whispering and be proud that you know things, because I think I heard it. What is it? Yes, thank you. And it's an acronym, and if you don't spell an acronym right, it doesn't help you, right? So you got to make sure you can spell it correctly. It is SOHCAHTOA, and I have a story about SOHCAHTOA that I'll read you when we're done with trig. Okay. So if you don't just know trig and you're not, I mean, it's going to be rusty for all of y'all because it's been a minute, right? But it's helpful to write SOHCAHTOA at the top of your paper anytime you're doing trig so that you can refer back to it. So let's talk about how we use this. Now, actually, before we get that far, sorry, I jumped ahead of myself here. Let's look at, we have 6 trig ratios, right? We have sine, cosine, and tangent, which are the 3 you learn in geometry. There are 3 more, cosecant, secant, and cotangent, okay? We're going to talk about all 6 today, but then we're really just going to work with these first 3 for a while and then kind of come back to the others. Because basically, if you can get sine, cosine, and tangent down, you're golden, right? Because they're the way that they're related. So you have sine, cosine, and tangent. Cosecant, secant, and cotangent are the reciprocals of them, okay? And you have to be able to pair them up correctly, which is tricky for some students at first. So we're going to talk about how they pair up, and I'm going to repeat that a lot, I'm quite sure. But I want you to look at these 6 words. Of those 6 words, 3 of them start with co, right? You see that? And then we're going to pair them up as reciprocal partners. But in every pair, there's only one co. That's important to remember. Which means that cosecant is not the reciprocal of cosine. That also means that sine is not the reciprocal of secant because there's no co at all. You with me on that? But nicely, tangent and cotangent pair up because that kind of makes sense, right? So cotangent is the reciprocal of tangent. Cosine is not the reciprocal of sine. That's not the way it works. Sine and cosecant are reciprocals, and then cosine and secant are reciprocals. So just remember one co in each pair, and the tangents go together, and then it's kind of hard to mess up the rest. Okay, you with me on that? And like I said, I'll repeat that. It'll all be fine as we get through it, okay? All right, so let's do these ratios. We've got this so part here means that sine is opposite over hypotenuse. So here's my sine. The way I read this right here is sine of theta. Sine of theta equals opposite over hypotenuse. This means that cosine is what over what? Adjacent over hypotenuse. And this means that tangent is opposite over adjacent. So if sine of theta is opposite over hypotenuse, then cosecant of theta is hypotenuse over opposite. If cosine of theta is adjacent over hypotenuse, then secant of theta is hypotenuse over adjacent. If tangent is opposite over adjacent, then cotangent of theta is adjacent over opposite. And in everything we do, I'm going to keep reminding you that I want you to think about cosecant, secant, and cotangent through the lens of sine, cosine, and tangent. Always take it back to those because those are the ones that you're going to be the most comfortable with, okay? I do that as well, and I know this way better than you do, right? I mean, I've been doing this forever. Okay, so let's talk about abbreviations and how to actually read the math. This right here, like I said, this says this is the sine of theta, cosine of theta, tangent of theta. This is sine, cosine, and tangent. It is not sin, cos, and tan. Let me say that again. It is not sin, cos, and tan. You say that, you sound ridiculous, okay? And you want to sound as intelligent as you actually are. So let's think of it this way. If you go to the doctor, and your doctor's name is Dr. Smith. Your doctor walks the room, and he was like, hey, how are you today? He was like, great, nice to see you, Durr Smith. You actually sound like a Durr, right? Okay, because you don't actually pronounce that Durr. That stands for doctor, yes? This stands for sine. This stands for cosine. This stands for tangent. This is not ksik. It is cosecant. This is not sec. It's secant. This is not cot. It's cotangent. You need to know those words, and you need to know how it all works, right? It's not that hard. Don't be a Durr. That's the lesson for the day. All right. Any questions at this point? We good so far? Okay. That really, except for these three, the reciprocals, the rest of it really should be a review. Okay. And why won't this work? Here we go. All right. Reciprocal functions. Because the cosecant, secant, and cotangent ratios are reciprocals, they are called reciprocal functions. All right. Now, how do we pronounce this? Cosecant. What is the reciprocal of cosecant? Sine. So cosecant of theta is 1 over sine of theta. And you would never have just like the SIN or the CSC kind of by itself in notation. That would be like having a random square root sign. So if we just wrote that down, we'd be like, square root of what, right? If I just write down sine, then it's like sine of what? So the sine of theta is the whole thing there. And how do we say this? Secant. And what is secant the reciprocal of? Cosine. So this is 1 over cosine theta. How do we say this? Cotangent, and that is 1 over tangent theta. Alrighty, so let's get into the nitty-gritty here. This says we're going to find the exact values. If you were finding exact values, there's a 99.9% chance that you ain't getting a calculator, right? One of the things you did a lot in geometry with trig was solve for missing sides and angles. We will eventually do that. That is not what we're doing right now, okay? We're just really finding the exact values of the trigonometric functions, which means we're just looking for the ratios. And mathematically, we're a ratio, we're looking for a what? fraction. If your fraction ends up being 5 over 1, then it can be a whole number. But it's not a decimal, and it's a ratio still, right? Okay, it's just like a hidden one. So here's my right triangle. I know it's a right triangle because it has a right angle labeled, right? Then I have to relate this to one of the acute angles. It's the one that's already labeled, so it's easy to figure out which one. So here is my angle. I'm going to draw my arrow across there. That makes that the opposite side. Then I have across from the right angle my hypotenuse, and then that leaves the adjacent side. Okay. So from SOHCAHTOA, sine is what over what? What is it? Opposite over hypotenuse. It is 4 over 4 square roots of 5. Can I reduce that fraction? Can I cancel the 4's out? No? Yeah, I can cancel the 4's out. I can cancel the 4's out. Does that just leave me with the square root of 5? No. 1 over the square root of 5. Very good. So 1 over the square root of 5. Now, are we allowed to leave it like that? No. Why not? Can't have a square root in the denominator, right? So what do? Anybody know what the fancy words are that make you sound smart? Well, we're not going to square it because I can't. Here's the thing. I can't change the value, right? But I'm going to rationalize the denominator. Doesn't that sound fancy and difficult? It's really not that bad. I'm going to do it over to the side, but we shouldn't have to go over to the side and do it because not only did you do this in geometry a lot, you also did this in algebra too. So I need to multiply this by a fraction that has a value of 1, so I'm not changing the value, right? So square root of 5 over the square root of 5. And when I multiply straight across, I'm going to get the square root of 5 over what? What's the square root of 5 plus the square root of 5? 5. So this gives me square root of 5 over 5. Okay. Cosine from SOHCAHTOA is what over what? Don't give me numbers, give me names. What is it? God, there's so many of y'all in here. Somebody speak to me. Thank you. Thank you very much, Gavin. So 8 over 4 square roots of 5. Can I reduce this fraction? Yes, that reduces to 2 over the square root of 5. Then I have to rationalize the denominator, which you don't have to go over there and write it, but if you did, you multiply by the square root of 5 over the square root of 5. I need to really learn to stop writing with my knuckles. Okay. You're going to get 2 square roots of 5 over what? 5. Okay. Then tangent is what over what? Opposite over adjacent. Thank you. So that is 4 over 8, and that reduces to 1/2. Okay. So we got our sine, cosine, and tangent. Once I can do sine, cosine, and tangent, the rest are a piece of cake. How do I say this? Cosecant. Okay. Now, cosecant is the reciprocal of sine, right? All 3 of these fractions, do you agree that they all have the same value? Yes, right? Because I have an equal sign there, so hopefully they have the same value. I could take this final value and take the reciprocal and rationalize. That's all fine and great. But could I choose a different one to make my life a little easier? Which one should I choose to flip over? I'm going to choose the second one, because if I take this and take the reciprocal, I get square root of 5, and I don't have to do anything else. If I actually made 5 over the square root of 5, and let me just show you that. If I flipped that and I got 5 over the square root of 5, right? So when I rationalize, that's going to give me 5 square roots of 5 over what? 5. And then those cancel out, and I just have the square root of 5. So it's just kind of extra work, and so it doesn't matter which one you do. All right, so then how do I say this? Secant. Which one would you choose to take the reciprocal of? The second one, because then you get the square root of 5 over 2, and a square root's fine, you just can't have it in the denominator. And then what's the cotangent of theta? 2. Very good. Any questions at all? We good? Perfect. Okie dokie. Then let's look at number 2. Got my, there we go. Here's my angle. So this is the opposite. This is the hypotenuse. This is adjacent. So when I go to do sine, I need opposite over hypotenuse. I don't have the hypotenuse. Do I have enough information to find it? Yes. By doing what? Pythagorean theorem. So I'm going to have 6 square roots of 3 squared plus 6 squared equals h squared. Now I want you to pause here for just a second and listen to me because this is very important. Actually, every word that comes out of my mouth is very important, but I really want you to hear this. What I have just written is not really 100% correct. And in the past, like if you have work like that and like I'll say something to you, they're like, oh, I know, but I know what to do, and then they do it right, was never really a big deal to me because I felt like most students that were doing that were actually writing things correctly when they needed to. AP-wise, that could be a huge problem because you have a linkage error and your equalities don't make any sense. Your work doesn't track, okay? And so I'm going to show you what I mean by that in just a minute. When you square this 6 square roots of 3, here's a couple of mistakes that happen. Number one biggest mistake is that you try to ignore actually understanding it and put it in a calculator, then you still get it wrong because you don't type it in the calculator correctly. And then the second mistake is never understanding what the heck to do. All right, so really I need parentheses here. And I want you to remember, okay, and I'm not going to step through this slow every single time. This is old business. You have to know how to do this stuff. When we talked about exponent rules, if I have a times b quantity squared, that is a squared times b squared, right? That makes sense? That's what you have to do here. This is a, this is b. What is 6 squared? 36. What is the square root of 3 squared? 3. So that's 36 times 3 plus 36 equals h squared. Okay? Then what is 36 times 3? 108, thank you, plus 36 equals h squared. So that means 144 equals h squared. So h is 12. Okay, we good with that? I'll take that as a yes. Okay, so now I need sine, opposite over hypotenuse, 6 square roots of 3 over 12. What does that reduce to? Square root of 3 over 2. Remember, you can do anything outside the square root together, anything inside the square root together, as long as there's no addition going on. That kind of throws off that always part of that. All right, cosine is adjacent over hypotenuse, so that is 6 over 12, and that is 1/2. Tangent, since y'all are mute today, it's opposite over adjacent, 6 square root of 3 over 6. And what does that reduce to? Square root of 3. See if you can get your reciprocals. Actually, I know you can get your reciprocals. Do the reciprocals. But don't look at mine until you're done. Or I think you're done. Anybody have any questions? And one of the things that I hope you learn kind of quickly is that if you look at this, the reciprocal of the square root of 3 is the square root of 3 over 3, right? So what do you think the reciprocal of the square root of 5 is? Square root of 5 over 5. What's the reciprocal of the square root of 50? Square root of 50 over 50, right? The reciprocal of the square root of a million, square root of a million over a million. The reciprocal of the square root of a monkey, square root of a monkey over a monkey. It doesn't matter what it is, right? So there's not a whole lot of work in there if you can recognize the patterns that start to happen here. All right, good. Any questions? Flip it over. So now it says use the given trigonometric value to find the remaining function values. So they give me the tangent of theta. So I'm going to go ahead and fill that in. 7 over 24. So what other value would I know right away? Cotangent, and that would have to be 24/7, right? Right in front of my face right now, do I have enough information to fill in the other 4? No, I don't, do I? So I'm going to need to draw a triangle. So I'm going to draw my triangle. I'm drawing a right triangle. Doesn't really matter what size it is. Just don't draw it microscopic so you can actually label it and use it. And then I'm going to put theta somewhere. I almost always put mine in the exact same place unless it's a story problem where things matter. I just, whatever, I just make them all the same. Okay, so if this is theta, then that means that this is opposite, this is the hypotenuse, and this is adjacent. I have the tangent of theta, so can I fill in a couple of side lengths? Yes? What's the length of the opposite side? 7, and this is 24, because tangent is opposite over adjacent, right? Gives me that ratio. Do I have enough information to find the hypotenuse? Yes. So 7 squared plus 24 squared equals h squared. That's actually a Pythagorean triple. H is 25. If you don't know your triples, that's fine. You just have to run through the Pythagorean theorem, but it's 25. Okay, so now set up your other 4 ratios. Any questions at all? Yes, ma'am. What did I do? Oh, I sure did. Dang it, thank you. I wanted to see if anybody's paying attention. I appreciate you paying attention. It's 25 over 24. All right, now any other questions besides why your teacher can't write things correctly? All right, so let's go and look at number 4. So secant of theta is equal to 4, so I can put that in right there. What other value does that help me know? Cosine, what would that be? 1 over 4, okay? So now we're going to do the same thing. I'm going to draw a triangle that's probably going to look almost exactly the same. That's totally fine. And I'm going to label it. This is the opposite, hypotenuse, adjacent, right? And then I have... Even though they gave me secant, remember I want you to look at everything through the lens of sine, cosine, and tangent. So we're going to use the cosine to help us label this. You could use secant. There's nothing wrong with it. I just kind of want you to get in the habit of that. Cosine is what over what? I know it's 1 over 4, but thank you. Adjacent over hypotenuse, so this is 1 and this is 4. This is not a Pythagorean triple, so we're going to have to do Pythagorean theorem. I'm going to use O even though it looks like a 0, and sometimes I confuse myself. But O squared plus 1 squared equals 4 squared. Oh, not 14. 4 squared. All right, so then that's not a 0, it's an O. And that's going to give me O squared plus 1 equals 16. So O squared equals 15. And when I take the square root, I technically get plus or minus, but minus doesn't make sense because it's the length of a side. So the opposite side is the square root of 15. Okay, we good? All right, I'm going to give you a second to fill in your other 4, and while I go check roll. All right, if you're still working on writing them, don't look up here until you're done. All right, so check yourself up here, and if once you understand, like if you've got a good grasp on everything and you don't want to write that, you just write that, and you don't want to write that, you just write that, I'm fine with that, as long as you know what you're doing. Don't start trying to skip steps if you're not comfortable with it, okay? What questions you got? We good? Beautiful. Okay, let's look at trig values of special right triangles. We are not going to be able to finish this whole thing today, so we're just going to do kind of parts of this and talk about special right triangles a little bit. So hopefully you actually remember doing, not that you could get up here and work all the problems right now, and that's okay, but in geometry you should have done a lot with special right triangles. You got your 30, 60, 90, and your 45, 45, 90. There are different ways to go about teaching this process, and I'm going to show you my way, which of course I believe to be the best way, or that's not the way I would do it, but it is a matter of opinion. So in a 30, 60, 90 triangle, you have a short leg, a long leg, and a hypotenuse. And everything revolves around the short leg. So the short leg's across from the smallest angle, so across from 30 here, we have S. And then the hypotenuse is 2 times S, and this is S times the square root of 3. You may have learned it using an X. I personally think that's a terrible idea because you could have a variable that's an X in your problem. You're much less likely to have an S, and then your variables don't get confused, okay? And then for a 45, 45, 90 triangle, you do have 2 sides and a hypotenuse, but the 2 sides here, what can you tell me about them? They're the same. They're congruent, right? These 2 sides are congruent. So I don't have a short leg and a long leg. I have a leg and a leg. And so we're going to use a lowercase l. Most of the time when you use a lowercase l in math, it's cursive, not because it has a different meaning, but so that it doesn't look like a 1. So this is going to be leg, leg. Anybody know what the hypotenuse would be? That's okay. I know it's been a minute. Leg times the square root of 2. So does that at least look semi-familiar? That makes me feel better if we look like, yes, we have seen this before at some point. Okay, so then we are going to come up with values so that we can actually find these ratios. And so we're going to say that in our 30, 60, 90 triangle, the short leg, we're going to say it has a length of 1. If it has a length of 1, then the hypotenuse has a length of 2. And then the long leg would have a length of square root of 3. You agree with that? And then in our 45, 45, 90, we're going to say the legs have a length of 1. And if that's the case, then what's the hypotenuse? Square root of 2. Okay. And of course, they could be anything. We're just trying to make the numbers simple so we can get through what we want to get through. Okay, so we'll probably get through the 30 degrees. Let's go ahead and just start on that. So for 30 degrees, which is what so right now, and I'm not going to write the opposite and adjacent on here because it's going to change. So we're here at the 30-degree angle, and we want to find the sine. So here's my 30. Opposite over hypotenuse, that's going to be 1/2. Cosine, adjacent over hypotenuse, square root of 3 over 2. Right? Nothing I can do with them. They are what they are. Tangent of 30, opposite over adjacent, so that's 1 over the square root of 3, which gives me square root of 3 over 3. And I'm going to leave that there. I'm just going to put an x through it because that's not really a value we're going to look at, but we used it and it's fine. Okay. Cosecant is the reciprocal of what? Sine, so that means it's just 2. Secant is the reciprocal of cosine, so that's 2 over the square root of 3, and then what does that become? Good, 2 square root of 3 over 3. And what would the cotangent be? Square root of 3, very good. Okay. Everybody good with all this so far? All right, so we're going to pause here until tomorrow. I'm going to need you to remind me where we are because I got to a different spot in second period, and I'm going to be all kinds of confused all day tomorrow, I'm sure.